Hello everyone and welcome back. So I wanted to go back here, and this is my propagating path, and we can use this sim if we it's better to use this sim and use a trail node. So I have the points cached here to disk, and let's set them to node geometry, and then if we trail them like this, we have the nice propagation. Okay, and actually this, okay, so if we use the prim class attribute, it's going to connect the points the way we want them. And with this, what we can do is we can they are dying off, so we need to extend this, but or switch it, do a time shift. And if the frame, sorry, we'll freeze it at frame 91, and then switch. And here we'll go to frame, sorry, 91. Okay, so we have the geometry, and I'm gonna put down an object merge and go back to this, and I'll simply grab the top layer. So I'm gonna copy all of this, and we have our points deforming. Okay, and we have these points. Where are they? Okay, and let's see if we are lucky and we still have the original position. Maybe we have a rest attribute. Perfect. So let's see if that gives us what we want. I want to flatten them back. Awesome. Yep. So my idea is this: we want to go back to the original sim, make sure it is packed, and use some sort of point deform to transform the geometry. Okay, so we have these points. Maybe we can even resample these curves so it's always the same. And let's compute the tangent. So I'm going to put down a polyframe. I'm going to compute the tangent. Okay, and let's also put down a wrangle node and store the position. We'll call this pause as P. And then I'm gonna unpack, or I'm gonna use the raw geometry so I can show it. And let's do an attribute transfer. And I want to transfer the point position, so pause. And I want to transfer, what else? The 10 as well. Okay, so we have those two. I'm gonna do it here because it's easier to see. And the other thing I want to do is I'm gonna create an assemble node, and I don't need the primitive, I don't need this. I'm gonna convert this into packed primitive and only show centroids. So each point has a centroid. I'm gonna create a wrangle node and call this v at centroid is equal v at p. I'm going to copy that attribute onto the mesh. So attribute copy from this to this, and I need the centroid, and I want to respect the name attribute. And if this doesn't work, we'll make sure the name attribute is a point. Primitive attribute. From point onto, from primitive onto points. Okay, so let's, I'm gonna cut this. Let's put down a point VOP. And I'm gonna bind import that pause attribute we transferred, and also the tangent attribute that we transferred. And let's plug this in, see what we get, just to make sure that we have data. Okay. And let's put down a subtract node and compare the position against the transferred position. And let's put down a length attribute, a length node. Compute the length of this. Interesting. And then we're going to fit range this between 1 and 0. Okay, so we have a white mask, and then we'll do 10. That's too much. We'll do 5. Cool. So we have the data transferred to the points. Well, I want the centroid, so bind import centroid. And let's plug this in as P. And that's going to give us all the points snapping onto their centroids. Now it looks like this geometry had a wrong name attribute, so for the time being I'm simply going to recreate the name attribute again. I don't know what happened there, and that should give us the result that we want. No? Why is this? Name attribute test centroid. Yeah, we have a centroid per each. Copy its point. Okay, so I'm not so sure why it's giving us this result. Let's put down extract centroid. Here. Yeah, it's working. So this is our centroid. 9.6. Okay, let's try copying it. This node also does the same thing. I just wanted to do it by hand. And I'm gonna copy the centroid. Create the centroid attribute. Copy it. Now all the points. Okay. I don't know what happened. It shouldn't be snapping to this. So let me quickly check what's happening, and then I'm gonna go back. I'm gonna come back. So it looks like the problem was in the geometry. So I simply imported the base version that I used in the RBD sim, extract points. I copied the attribute into the point position into center, and then copied that over. If I plugged into the point position, everything snaps. And if we do a blend shape between the two, we can do this. Okay, so I needed that centroid because I will use it to rotate the points or add an offset based off of that. Let's continue. So we have our center attribute, and we have our multiplier. And what we can do is we can put down a transform, transform. Let's see. No. Translate. No. Yeah, transform matrix, sorry. So we want to transform the current position. Let's plug this in. I'm going to disable the mask. The pivot is going to be the centroid because we want to rotate each piece based off of that. And now if we do this, if we rotate the pieces, you will see we're getting this. So if we simply mix between this position and the current position using this mask, we can get that. So let's flip in between. So we can affect only the points that are being affected by the curves, and if we play through, we will get this. Okay, so this is just a quick idea, and we can also rotate by quaternion angle, quaternion. Yeah, let's try this. Point position. And the axis is going to be, let's try this. So that's not the axis. I'm gonna normalize the tangent. And this is, again, I'm not sure if this is going to work. This is the axis. And let's reduce this. Okay, so it looks like it's doing something, but because it's affecting all the points at the same time, let's do flat shaded. Because it's affecting all the points, if we use packed primitive and do this operation on packed primitives, we should see better results. And the tangent right now is coming from those from the curve, so it's following along the curve. If we do a cross product and try different orientations, we will get nicer result. So this one looks like it's tilting the pieces along the correct axis. And then if we mix this, if we mask that with the noise, we will get some nice deformation happening. And all this has to happen, yeah, you see it there. All this has to happen at the packed primitive level, so that when we do all this, it's only going to affect the pieces. It's not going to affect the geometry. So let me try that super quick. So maybe it can work if we do this. So now I don't need to change. Let's put down packed. Yeah, so see, by just doing that, because it's affecting entire piece, not just the points, we're getting nicer effect. And we'll see now. It's giving us nice randomization to the pieces as the curve grows. And because we're doing it at this level, now when we connect or we transform this, let's hope the name attribute didn't get messed up. It's going to work nicely. So see that ripple there? It's coming from the curves. And see this separation here? It's all coming from the curves. And we can obviously tweak this and make sure we get the nicer result than this. But that's the idea. We transfer the curves as a mask and then use whatever direction or orientation you want. You can even just add a small offset to the pieces and mask it. For example, we could do something really simple and take the vector to float. I want the y coordinate, and then I'm gonna say set component, set vector component, and this is going to be the second component. And I'm gonna add a noise to the y-axis. So noise, let's put down noise position like that, and then let's connect it. Which one? So we'll add it on top of the transformation as well, or the transformation. So that's an offset along the y-axis. It's too strong, so we'll lower to 0.05. 0.1. I'm gonna use only the offset. I don't think it's working with the quaternion. So let's set it to 1, something like that. And then if we hit play, we're gonna see a small ripple happening. And then if we transform this, it's going to work. That's it. That's all we have to do to get some curve deformation back onto the geometry. Thank you guys for watching, and talk to you soon. Bye bye.